Hello everyone. Today we'll be starting a new chapter that is correlation and regression. So, two different topics but related to each other. So, as we first did statistical description theory where we learn about the terminologies. Then we learn central tendency, mean, median, mode. Using that, we calculate dispersion, mean deviation, quartile deviation, standard deviation. Now, using standard deviation in some cases, we will be finding out correlation. So whatever we have done till now, whether it's central tendency or it's a dispersion, we were only talking about a single variable data. You were only talking about one parameter in question. If you are talking about marks, you found out average marks, standard deviation of marks, deviation of marks. You only talked about one parameter, one variable, one characteristic. But in general, there are also situations where more than one variables are concerned. For example, if I have height and weight, I want to study them together, price and demand or price and supply. I want to study them together. So now what we are going to study are multivariable distribution, and in particular, we'll be talking about bivariate distributions, right? So entire correlation and regression chapter is studied for bivariate data. That means there will be two variables. We'll be studying about two parameters together, two variables x and y in together. As soon as we have two variables, the first question that comes is whether they have a relation between them, whether there is a connection between them. What do we mean by connection? For example, height and weight. I'm studying those two variables. Okay. So as soon as I say height and weight, if the height of a person was earlier 5 feet and has now become 5 foot and 7 inches, so obviously the height being more, the weight of the person will also be more. So increase in one variable, increase in one parameter will automatically lead to an increase in the other variable. That means one variable does have an effect on the other. When we talk about price and demand, if I increase the price of a commodity, then automatically the demand of that commodity what decreases, right? Law of demand. So in this case, again, the effect in one variable is seen in the other variable. In this case, it has negative effect. If I increase the price, the demand gets reduced. Whereas in height, if I increase the height, the weight also gets an increase. So this was same direction, increasing. But when it came to price and demand, it was different direction. It was negative. So in some cases, it will also happen that the two parameters are not at all related to each other. For example, if I'm talking about marks in BST and marks in mathematics, they're not connected to each other. Student may either be good in both, or maybe bad in both, or maybe good in one and not that good in the other. It may be any such way. They're not related topics, right? They're not related things. So, shoe size and intelligence. If the person's shoe size is more or less, it has no impact on its intelligence, right? So, if I'm studying parameters, if I'm studying two variables, if I'm studying a bivariate data, the first and foremost thing that may come to us is whether there is a connection between them. And if there is a connection, what type? Height weight type. That increase in one is increasing the other, or it is price and demand type, increase in one results in decrease in the other. And if there is a connection, can I form an equation? Like, for example, you have a data for height and weight. Can I form an equation for height and weight so that now if I say that the weight of a person is 56 kg, you'll tell me the approximate height should be this much. If I tell you the weight of a person is 6 feet, a height of a person is 6 feet, you tell me that the approximate weight should be this much. Can we form such a mathematical relationship between the variable? And if yes, that means I'll be able to find the value of one variable when the value of other will be given. So these are the certain points that we are going to talk about in the chapter correlation and regression. But before talking about in detail about that, we'll first study bivariate data. So what is a bivariate data? Any data which concerns two variables x and y. Any data which concerns two variables x and y. And the distribution that is provided for a bivariate data, the distribution or the distribution for two variables together is known as bivariate frequency distribution or joint frequency distribution or two-way classification. So how will the data look like? It's going to look like this. This is a bivariate data where we can see marks in maths as well as in statistics in the same table. In the same table, you can see maths of marks of math subject as well as statistics subject. So if I talk about this one student, so it belongs in this category. So this particular student has got marks in maths between 0 to 4 and in statistics has got marks between 4 to 8. Do you all agree with this?
Yes,
Yes,
ma'am.
ma'am.
What about these three students, the frequency 3? These three students have got marks in maths between
8 to
8 to
12.
12.
8 to 12 and in statistics between
12
12
to
to
16.
12
16.
to 60. So such a distribution is known as a bivariate frequency distribution or a two-way classification or joint frequency distribution. So what we will have is we are going to study such type of a data. But in our content, we are only going to talk about ungrouped data. In correlation regression for now, we are only going to talk about ungrouped data. We are only going to talk about individual series data, ungrouped data, no frequency cases here. Okay. Now, that it exists, but we will not study. It's not there in our content. Now, from here, from a bivariate data, we can talk about two different types of distribution. We can either form a marginal distribution or we can form a conditional distribution. What do I mean by that? Can you all tell me how many students in total have got marks in mathematics 4 to 8? Between 4 to 8 in maths, how many total students?
8, ma'am.
So, the total of maths 4 to 8 is 8 students. These 8 students have got the marks in maths between 4 to 8. Do you all agree?
Yes, ma'am.
What is the total of 8 to 12 in maths?
15.
15.
50. So from a bivariate data, let's first talk about marginal distribution. What do I mean by that is, what are the two variables we are talking about here? What are the two characteristics in we are talking,
Marks in maths and statistics.
right? So what I can do is I can separate them. Marks in maths as one table and marks in stats in another table. That means from two variable, I'm making it a one variable data. I'm dividing it into one variable. So marks in maths, I have column 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20. Frequency. What will be total of 0 to 4 in maths?
3, ma'am.
3, ma'am.
3. 4 to 8,
8.
8.
8 to 12,
15.
12 to 16,
14.
14.
to 16 to 20,
10.
10.
10. Now, if we add, we are going to get 50. So from a bivariate data, I have first constructed another one variable data. The variable is only maths. In the same way, I can also construct a data. I can also construct a data for stats. I can also construct the data for stats. So for stats, we have the same columns. Let's talk about frequency. So 0 to 4 in stats,
4.
4.
4 to 8,
12.
8 to 12,
14.
14.
then
11,
11.
and 9.
9.
If you find out the total, it's again 50. So marginal does what? From a two variable, it makes it one variable. It makes it single variable completely separate. So now you think and tell me, from a bivariate frequency distribution, how many marginal distributions can be constructed?
2.
2. It's always going to be 2. If you are talking about two variable x and y, there will be one marginal distribution for x and one marginal distribution for y. Do you all agree?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Now let's talk about conditional. Let's talk about conditional. Now, what will happen in conditional is, I want to find a table for marks in maths, but I'm going to give you a condition that take only those students in maths. I'm constructing the table for marks in maths, but I'm going to put a condition on the other variable that you only take those students in this table, in the maths table, who have got statistics marks between 8 to 12. Form this marks in maths, but condition is stats marks should be between 8 to 12. So you take only those students in your table who has got marks in statistics between 8 to 12. So now you tell me how many students have got marks in mathematics 0 to 4, provided they have got in statistics 8 to 12.
1.
1. Do you all agree?
Yes, ma'am.
Yes, ma'am.
We are only allowed to take this table. So here the frequency will be 1, then 2, 4, 6, and 1. Do you all agree?
Yes, ma'am.
So I form the table for X for maths, but I have put a condition, another condition on statistics. So now you tell me for maths, how many such tables can be constructed if I'm putting the condition on statistics?
5.
5. This can be a condition, second, third, fourth, fifth. I can have 5 different tables for maths.
Yes, ma'am.
So 5 conditional distribution can be constructed for marks in mathematics. Fine. What about statistics? If I write here stats, I'll put the condition on what? I'll put the condition on maths.
Yes, ma'am.
So this can be a condition 1, 2, 3, 4, 5. Again, in this case, for statistics, there can be 5 different conditional distributions again.
Yes,
Yes,
ma'am.
ma'am. Yes.
So in total, how many conditional distributions are possible?
10.
10. Do you all agree? Why? Because there are 5 rows and 5 columns. So each row and each column becomes a condition for one of the table. Yes or no? So from a bivariate data, how many marginal distributions can be formed?
2, ma'am.
Only 2. One for X, one for Y. How many conditional? Number of rows plus number of columns. If there are 6 rows and 3 columns, how many conditional distributions?
9.
9.
9. If there are 5 rows and 7 columns, how many conditional distributions?
12.
If there are P rows and Q columns,
P plus
P plus Q.
I can also say that the classification is P by Q. So now if you see there are 5 rows and 5 columns, how many entries are allowed? Here 5 entries, these are 0. What can we do? Then next row 5, then 5, then 5, then 5. So in total 25 cells, 25 entries are allowed.
Yes, ma'am.
Yes, ma'am.
So if I tell you that there is a classification M into N, a bivariate frequency distribution has M by N classification. You tell me how many marginal distributions are possible?
2, ma'am.
Conditional.
M
M
plus
plus
N.
N.
M plus
How many entries or cells?
M into N.
Mn. Everybody clear?
Yes, ma'am.
Yes, ma'am.
So this is
Yes.
what we will be needing. from P by Q bivariate data. Number of marginal distributions. 2. Number of conditional distributions. P plus Q. Number of cells or entries. P into Q. Understood?
Yes, ma'am.
Everybody written?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Can you wait?
Yeah. When you're done, let me know.
I'm written.
Okay. Now we'll move to the actual table. So as I said, if I have two variable, what are the questions we ask? Whether there is a relationship between them or not. If there is a relation, what type of a relation is there? And then whether I can form a mathematical relationship that is an equation between them or not. And so why? So that if I give you X, you'll be able to find Y or vice versa. So some things correlation does and some of the things regression will do. So what does correlation does? First, helps us to understand whether there is an association or lack of association between the variable, whether the two variables are related or not, right? Height and weight, price and demand, or completely unrelated like shoe size and intelligence, business studies marks and mathematics marks. So whether there is a link between the two parameters or not, whether a change in one parameter affects the other variable or not, that thing correlation tells us. So first point tells us about the association or lack of association between the two variables. And if there is an association, what type? Whether increase in one will result in increase in other, or increase in one will result in decrease in the other, that nature of a relation will also tell us an extent. That means, for example, the height was 5 feet, then it became 5 foot 1 inch. So the difference is very less. So what type of an effect will it have on the other variable? Whether a slight change in X will have a drastic impact on Y, or it will not be bothered. So, what is the extent, whether there's a very strong chemistry or a weak chemistry between them? That is also helped us to understood in this topic. Second, nature and extent of relation. This is also written in correlation, obtained in correlation. What does it not do? It does not form a mathematical equation, and because of which we will not be able to find the value of one variable when the value of other will be given. So third drawback, does not form a mathematical relationship between x and y does not help to find the value of one variable when the value of other variable is given. So first helps us to understand about the association or lack of association between the variable. The nature and extent is also obtained here, but it will not form a mathematical relationship between the two variables, because of which we will never be able to obtain the value of one variable when the value of other will be provided. Any doubt till here?
No, ma'am.
No,
Now, sometimes there is no direct relation. For example, demand and supply. There is no direct relationship between them, but they are connected because of the factor price. Price affects both of them. So we say that demand and supply will be related because of the presence of price. Area and circumference of a circle, they're not directly related, but they're both related to radius. So sometimes X and Y may not be directly related. They may be related because of a third party. So, such lack of causal relation is known as spurious correlation. Just a theory point. Spurious correlation. Just remember the word no causal relation. Just remember this word. No causal relation. Okay, can you tell me central tendency? Was it affected by change of origin?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Scale,
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
dispersion? What about that?
Only scale, ma'am.
Only scale, only the multiplication word.
Yes, ma'am.
Now, for example, every single time whenever we are talking, we had what symbols. For mean, we had x bar. For standard deviation, we had sigma. Quartile deviation, we were saying QD, right? Similarly, now for correlation also, we have a symbol. We use the symbol small r, and that is known as correlation coefficient. The measure, the value denoted by small r. The value that we'll find for correlation is given to the variable r. Now, what are the properties? R has no unit because it is a ratio. When you see the formula, you'll always see something by something. So, since it is a ratio, it can never have a unit. It is a unit-free measure. It is a unit-free measure. Second, the value of R lies between -1 and +1, both included. The value of R lies between -1 and +1, both included. Third, neither affected by origin nor by scale, only by scale factor. Now, what do I mean? Understand, now this is very important. For example, correlation between x and y is 0.8. So what is the maximum value of R1? And R we have got 0.8. That means the connection between X and Y is very strong.
Yes, ma'am.
And since it is positive, it will form a positive correlation. That means increase in one will lead to an increase in other. Since R is positive, therefore, if I increase the value of X, Y will also increase. If I increase the value of X, Y will also increase. Till here, any doubt?
No, ma'am.
Okay. Now, what I'll ask, what I meant by origin and scale is, suppose in X, I'm changing to U. See, earlier you had only one variable X. So you are changing it into Y. Y is equal to 2X plus 3, Y is equal to 3 minus X. Now there are two variables, X and Y. X will also be changed to something. Y will also change to something. Suppose X is multiplied by 2 and subtracted by 3. And Y is multiplied by 3 and added by 5. So as I just said, it is not affected by origin. That means if I add or multiply something, it doesn't matter. Right? Again, it is also not affected by scale. So if I multiplied 2 and I multiplied 3, it doesn't matter. What matters is scale factor. That means the sign. So I multiplied X by a positive number, multiplied or divided, whatever. In our case, I have multiplied X by a positive number,
Yes, ma'am.
right? And I've also multiplied Y with a positive number. Since the sign is same, what do I mean by positive is, since X is multiplied by a positive number, so if X increases, U will also increase. Since Y is multiplied by a positive number, when Y is increased, V will also increase. So when this was happening, instead of X, I can write U. Instead of Y, I can write V. Can you see that U and V are also in the same sign? And if you're not able to understand so much, just remember, what I multiplied with X and Y, are they of the same sign?
Yes, mom.
Yes, ma'am.
Then R, U, V, correlation between U and V will remain the same. Whatever it was, it will remain the same. If the question would have been Rxy is minus 0.2 and U is 3 minus 2x, V is 5 plus 6x, 6y. Okay. Now we need to find out RUV. So X is multiplied by a negative number, Y is multiplied by a positive number. So the sign is different in both the case.
Yes, mom.
Yes,
So
ma'am.
whatever the original value of R was, change the sign this time. You need to change the sign. So my answer will be plus 0.2. The value will never change. The only thing that can change is sign. If I tell you, suppose P is x minus 3 by 5 and Q is y plus 2 by 5. Can you tell me what will be RPQ?
Minus 0.
0.2.
Since both of them are divided by the same positive number, same sign, so whatever the original R was, it will remain the same. It will remain the same. Clear?
Yes, mom.
Yes, ma'am.
Yes, mom.
Everybody clear?
Yes, mom.
Yes, ma'am. So what is R? R is correlation coefficient. It is a ratio. It will not have a unit. It is a unit-free measure. The value lies between -1 and 1, both included. It is neither affected by origin nor by scale, only by the scale factor. That means only by the sign. Clear?
Yes, ma'am.
Now, we'll study how to calculate measures of correlation. 4 types. There are 4 measures. First, scatter diagram. It's just theory, no sums. Second, Carl Pearson product moment correlation coefficient. In each case, you are only going to find the value of R. The symbol remains the same. Only the formula keeps on changing. Third, Spearman's rank, correlation, coefficient. And fourth, coefficient of concurrent deviations. The little longer one is the second one. First is theory only. Third and fourth are very simple formulas. Second one is a little larger formula. Done?
Yes, ma'am.
Now we'll study the first one, scatter diagram. Pure theory. What does it say? See, you'll have x and y both, right? What will your question look like? 20, 12, 30, 24, 26, 18. The data will look like this, right? Since we are only going to talk about ungrouped data, we are only going to talk about individual series data. Okay. So I can plot here. X values will be plotted here. Y values will be plotted here. So how the values look like, that will determine what type of correlation do we have. Okay. So in scatter diagram, x comma y are plotted in the Cartesian plane, and the way the dots are arranged, that will tell us how the data, how the correlation between the two variables will be like. So first is positive correlation. In case of positive correlation, the data will look like this. When you plot the data, the values will be concentrated on almost going upward. Almost going upward. The values move from lower left to upper right. What does it mean? As we move here, the values of x are increasing, and as we go up, the values of y are increasing. That means same direction movement. Same direction movement. That is, increase in x, increase in one variable results in increase in other. If you are increasing x, y will also increase. If you are decreasing x, y will also decrease. For example, height and weight. Example, height and weight. And in this case, the value of r will be between 0 and 1. The value of r will be between 0 and 1. Everybody understood? It's pure theory, no sum set.
Ma'am.
Then we have perfect positive. So what will happen here is the values will move from lower left to upper right, but they will move in a straight line. Perfect straight line. Values move from lower left to upper right in a straight line. Everything else is same. Same direction, increase in one results in increase in other, decrease in one results in decrease in other. Everything else is same. And in this case, R will be plus 1. R will be plus 1. For example, 2x minus 3y equals 6. Remember, correlation is obtained between x and y. Earlier, I gave you two relations. From x, we found u. From y, we got v. So we had x and y, then we got to u and v. Now, what I've given is original relation between x and y. So it's a linear equation. I want to find out correlation between x and y. So is it not a linear relation? The power of the variable is 1.
Yes,
Yes.
ma'am.
Separate any one variable, whichever you want. Separate a variable. Suppose I separate x. Now just no origin and scale effect, right? Just see the sign before y. Is it plus or minus?
Plus.
Plus.
Plus. So since it is a linear equation, it represents a straight line. So either it will be perfect positive or it will be perfect negative, depending upon the coefficient of the variable is positive or negative. Since coefficient of y is positive, R will be plus 1. Understood?
Yes, ma'am.
Ma'am.
Then we have negative correlation. So the values will be scattered somewhere around here, but they are going to move downward. So values move from upper left to lower right, opposite direction. Increase in 1. So x is increasing, but the height is going down. So y is decreasing. Increase in one variable results in decrease of other. Price and demand. Here, the value of R will be between -1 and 0.
Ma'am.
Yes.
Basically, this method tells us that how much is the relation between x and y, or
How much it won't tell us. Did I ever give you a formula? Will you ever find out what is the actual value of R if it is not perfect? Like negative.
oh,
You know that the value will be between -1 and 0, but you will never know how much. Why? Because there
okay.
is no formula. So it will tell you the nature, whether it is positive relation or negative, but it will never tell you the extent. R is 0.2 or 0.8. It will never tell you that.
Oh, okay, ma'am.
Perfect negative. The points will move downwards. Values move from upper left to lower right in a straight line. R will be -1. Now here, suppose I have 2x plus 3y equal to 6. It's a linear equation. So either R will be +1 or R will be -1. Separate a variable, any one variable. Suppose this time let's leave y. So the coefficient of x is a negative number. Since coefficient of x is negative, so value of r will be -1. Value of r will be -1. Clear?
Yes, ma'am.
Zero correlation. R will be 0, uniformly distributed. That means you will be able to predict. How? Example, x, y. Can you see that you are able to see a pattern between x and y?
Yes, ma'am.
So you don't need to calculate. No formula necessary. R will be 0 straight because it is uniformly in a predictable patternly distributed. Understood?
Yes, ma'am.
Yes, ma'am.
Also, in case of curvilinear correlation, here it will be like spiral. You will be able to predict. Curvilinear correlation. If it is not forming a linear equation also, then also in some cases R comes out to be 0. So when R is 0, it does not mean zero correlation. It can also mean curvilinear correlation. If R is 0, it can mean both zero correlation or curvilinear correlation. Clear?
Yes.
Yes,
Yes.
So points in scatter diagram. We have no calculations involved. We have no calculations involved. We find nature of correlation, positive or negative, but not extent. I can tell you whether R is positive or negative, but I can't tell you how much will it be. Whether R is 0.2 or R is a 3, 0.3. I won't be able to tell you that. Everybody clear here?
Yes, ma'am.
So the first thing we talked about was a bivariate data. So what is a bivariate data? Where two variables are involved. It is also known as two-way classification or joint frequency distribution. In format 2 bivariate data, we can form marginal distribution and conditional distribution. So if it is a P by Q classification, how many marginal distributions exist?
2.
2.
2. How many conditional?
P plus Q.
Plus
P
Q.
plus
And
Q.
how many entries are there?
P into Q.
into
P
Q.
Q.
P into Q. Clear? Then comes your correlation coefficient. Correlation coefficient is denoted by smaller. The value is always between -1 and 1, both inclusive. It does not have any unit, it is a ratio, obviously. Then the value of R is neither affected by origin nor by scale, only by the sign, that is scale factor. Clear?
Yes, ma'am.
Then we talked about measures of correlation. There are 4 measures of correlation: scatter diagram, Curl-Pearson product moment correlation, Spearman's rank correlation, and coefficient of concurrent deviations. From the first one we talked about, that is scatter diagram. It is completely theoretical where x and y are plotted, in which you only get to know about the nature, but we don't get to know about the extent because there is no mathematical formula and calculations involved. Now, when it comes to positive correlation, movement is from lower left to upper right. It goes this way. R can be from 0 to 1, same direction, increase in one, increase in other. If they move from lower left to upper right in a straight line, then it will be R will be +1, perfect. right? It's a perfect positive correlation. If the values move from upper left to lower right, the negative correlation R lies between -1 and 0. Increase in one variable will result in decrease in the other. It has opposite direction movement. But if they move from upper left to lower right in a straight line, then it is a perfect negative correlation. R will be -1. If R is 0, it can be a zero correlation also or a curvilinear correlation. Yes. In case
Yes.
of 0, we can write the example, show size and intelligence. Clear? Everybody done?
Yes, ma'am.
Yes, ma'am.
We will first talk about the last number, coefficient of concurrent deviation. Pretty easy to do. Now, this method is not concerned with the actual value of the variable, is not concerned with the magnitude. Why? I'll tell you. Okay, let's take the help of an example first. Wait, X and Y. 25, 28, 30, 23, 35, 38, 39, 42. Y. 35, 34, 35, 30, 29, 28, 26, 23. This is your data. And question is find the value of R using concurrent deviation formula. Now what we do here is we allocate sign. We allocate sign. If a number is greater than the previous number, we will write a plus sign. And if the number is smaller than the previous number, we will write the negative sign. So obviously the first number 25 cannot be compared because there is no number before that. So for 25, we cannot allocate a sign. We start from the second, 28. So 28 is larger than 25. So we allocate a plus sign. 30 is larger than 28. We allocate a plus sign. 23 is smaller than 30. We allocate a minus sign. Then what about 35?
Plus sign.
Plus sign.
Plus 38,
Plus sign.
No.
39,
Plus sign.
42.
Plus.
Plus sign.
So there were in total how many data? 8 observation. But how many signs did I allocate?
7.
7. It will always be one less. Always. So first symbol, understand the symbol here. First symbol is M, number of deviations, number of signs basically, right? It will always be one less than the number of observation. Do you all agree? If there would have been 10 observation, first number cannot be given a sign. I can only assign sign to the next 9 numbers. Do you all agree?
Yes, ma'am.
Yes, ma'am.
Now, let's do the same thing for Y. 35 will not get a sign. 34,
Minus.
35,
Plus.
30,
Minus.
Minus.
29,
Minus.
28,
Minus.
Minus.
26,
Minus.
Minus.
23.
Minus.
Minus.
Now we will have product of deviations. Multiply the signs. We need to multiply the sign. So I hope you all remember plus multiplied by plus is plus, plus multiplied by minus is minus, minus multiplied with minus is plus. So plus minus
Minus.
plus plus
plus
plus
minus minus.
plus
plus
Now all of these will be multiplied to give minus.
minus.
Till here, anyone has any doubt?
No, ma'am.
Ma'am.
So if you actually see, I'm not concerned whether it is 34 or 35. I'm only concerned with greater and smaller. That's why I said that this formula is not concerned with the magnitude of the data, only sign, more than, less than. Did you all understand this?
Yes, ma'am.
Next symbol is C. Number of concurrent deviations. That means number of positive sign in product column. In the product column, how many positive signs are there? That is what C is. So how many positive signs are there?
2,
C will be 2. How many signs did I allocate in total?
7,
1, 2, 3, 4, 5, 6, 7. There were 8 data, but we always allocate one less. So M will be 7. Till here, any doubt?
No, ma'am.
Now, the formula is, I'll tell you why it is plus minus. This is the formula. 2C minus M by M. So R 2C minus M by M. Calculate. 2 2s are 4 minus 7 by 7. Under root minus 3 by 7. So for us, just imagine that the minus sign comes outside. If the inside term gives you a negative sign, the actual value will also come out to be negative. So minus root 3 by 7. For us, it will work. Understood?
Yes, ma'am.
So how much is R? Calculate.
0.654.
Minus 0.65. All of you understood?
Yes, ma'am.
Yes, ma'am.
Guys, clear?
yes, ma'am.
Yes, ma'am.
Yes,
So this
ma'am.
is the easiest one that we have. Will you try one question? X 35, 38, 40, 33, 45, 48, 49, 52. Y 36, 35, 31, 36, 30, 29, 27, 24. Try.
Ma'am, is it -1?
Yes, ma'am.
Okay.
-1.
Let's see. Plus, plus, minus, plus, 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 plus. Minus, minus, plus, minus, 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 minus. So M 7, C product C is 0.
Yes, ma'am.
under root 9. So minus 1. Any doubt?
No,
No.
ma'am.
No, ma'am.
All of you clear?
Yes, ma'am.
Yes, ma'am.
So scatter diagram, pure theory. Concurrent deviation is only this much. Any doubt till here?
No, ma'am.
Ma'am.
Then we have Spearman's rank correlation coefficient. Now, it is only used for qualitative characteristics, yani attributes. For qualitative characteristics, that is attributes. It is used, for example, in a competition, we have assigned 2, 3 judges, whether the judges are in agreement with each other or not, or someone supposed to contestant takes rank, judge one says the first rank, and the second judge says the last. So that is perfect disagreement. That is not going to be possible, right? A judge may not like a contestant to the same extent, but it cannot be that one loves and the other hates it. That much can't happen. So whether the judges are in agreement with each other or not, that is also we see in this particular case. Agreement or disagreement between judges is seen here. So if there is a perfect agreement, both of them have given the same ranking, then R will be +1. Perfect disagreement. If one is given the first rank, the other has given the last rank. So R will be -1. For example, 2x, judge 1, 1, 2, 3, 4. And judge Y is given the same contestant, this order. Exact opposite order, exact opposite ranking. Yes or no?
Yes, ma'am.
So
Yes,
this
ma'am.
will be perfect disagreement. So I don't even need to apply the formula here. What will be R?
Minus.
Understood?
Yes, ma'am.
Now I'll write the formulas. I'll explain you with the help of sum. What does it mean? Number 4. R is 1 minus 6 summation d square by n square minus 1. This formula be used without time. When there is no time. Yeah, we use this formula. T cube minus t whole by 12. Whole thing divided by n square minus 1. In case of that. I'll explain you what does it mean. D is difference in rank. Pretty easy. Don't worry. T number of people died. Done?
Yes,
Yes,
ma'am.
ma'am.
Okay. Question. I'm gonna give marks. Okay. I'm giving you marks right now. These are the marks. What we will do is we'll first give them ranking. Now, ranking you can give them in ascending or descending order as you please. But if in X we are going ascending order, in Y also we will go ascending order. Same, whichever you please, but the order has to be same for both the variables. So let's say ascending order from smallest to largest. So in X, the smallest score is first 35, second
41.
41, third,
45.
fourth is 55, fifth is 62, sixth is 72, seventh is 85. Any doubts?
No, ma'am.
Try the ranking for Y. Same order, smallest to largest. Try the ranking for Y. So the first is 31, second is 47, sorry, 35, third is 47, fourth is 50, fifth is 62, sixth 70, seventh is 95. Now D is difference in rank. Subtract the yellow ones any which way. 1 minus 6 minus 5, 6 minus 5 1, 3 minus 3 0, 5 minus 2 3, 7 minus 7 0, 4 minus 4 0, 2 minus 1 1. B square. Calculate total.
36.
36.
Was there any tie? Does any two observations were same? Were any two observations same? All the observations are distinct, no? There was no same score given to any two contestant, right?
Yes, ma'am.
So we will use the first formula. R 1 minus 6 summation D square n square minus 1. 6 summation D square, sum of the difference in rank. N is obviously number of observations. How many data were there?
7.
7 into 7 square minus 1. Calculate and tell me.
0.357.
35, ma'am.
Very good. 0.357. Any doubts?
No, ma'am.
No, ma'am.
So this formula will be used when any two observations are distinct. All the rankings are different. So in some cases, like here, we saw that the data was not arranged, right? So obviously it wasn't ranked. Sometimes we'll give you the rank itself. How? X 3 1 4 5 6 2. Y 4 3 7 6 2 1 4. If you can see, it is already in the serial order. 1 2 3 4 5 6 7. Yes or no? The data are all consecutive, no? Someone is 1, someone is 2, then 3, then 4, then 5, then 6, then 7. Yes?
Yes, ma'am.
Yes,
So
ma'am.
that means they have given you the rank. You don't need to find the rank. These are the ranks. So you can directly start with the difference. Understood?
Yes,
Yes,
ma'am.
ma'am.
So D 3 0 minus 6 minus 2 3 5 D square. Find the total. Find the
87.
total. 87. We will use the same formula. 1 minus 6 summation d square n square minus 1. 1 minus 6 into 87. 7 into 7 square minus 1. Answer.
Minus 0.55.
Understood?
Yes, ma'am.
Yes, ma'am.
All of you agreed?
Yes, ma'am.
Any problem?
No, ma'am.
No, ma'am.
No, ma'am.
The second formula will continue in our next session. I hope you all understood all the sums today. Revise it and we'll continue tomorrow. Thank you.